The AN PRC-74 is possibly one of the best HF single sideband backpack transceivers reproduced in the 60s. Introduced in 1966, it covers 2 to 12 megahertz and 1 kilohertz steps and puts out about 15 watts of CW or single sideband voice, upper sideband only, and has the ability to work with early coding equipment to do 300 words per minute burst keying. We'll go ahead and take this one apart. Take the handset off. Flip the legs in. Move the battery box from the bottom of the unit. These work real well on just a 7.5 ampere hour SLA gel cell battery. So your function switch has the on, off, and tune function. The RF gain control. Megahertz selector. 100 kilohertz. 10 kilohertz. And 1 kilohertz step. It's also the RIT control, and that also doubles as a calibrator control. They call this peak, but it's actually tuning of the RF stages. Then there's the antenna loading and antenna capacity. We'll go ahead and pop this radio open. And let's just look at the functional block diagram. It's pretty straightforward, single conversion. There is a synthesizer module, an RF deck and amplifier, mixer, IF deck, which is for both receive and transmit, and a 1.75 megahertz source. The IF in this is at 1.75 megahertz. Looking at the top of the radio, we can see where the synthesizer assembly is. The 1.75 megahertz reference oscillator. The IF and audio decks for both receiver and transmitter. The power supply. And the RF deck and RF power amplifier. The power amplifier is on the left-hand side. We'll go ahead and put power to the radio. As I've mentioned before, this is a 12-volt radio designed to run from battery packs. Hook the audio cable up to it, and in this case, these didn't have a whole lot of receive audio, so I'm actually using it with this little external amplified speaker here you see in the black. Take a signal source, hook it to it. We'll go ahead and turn the radio on, and we'll set a frequency on it. We'll do 5357. And after you set the frequency, you go back and peak noise on the radio for maximum static. And then you can go ahead and calibrate the radio by pushing in the calibration control. And you zero beat it. And once the zero beat's done, you release it. You should be relatively close, if not directly on frequency. So in this case, I'm going to set the signal generator to 5358. With the radio set at 5357, that should give a 1 kilohertz tone on the output of the radio. So there's 5358. If we look over on the scope, we could see we're just above 1 kilohertz. So it's pretty much dead on frequency. But you can vary it one way or the other with the RIT or clarifier. Take and move it over to the dummy load. Push it down into tune, which forces it to transmit. And then what you're going to do is use the loading and tuning controls along with the little bitty meter to peak the meter for maximum output. And that'll be about 15 watts. So now the PA is all tuned. And the radio is basically ready to go. Talk a little bit about some of the technology here. You saw the top, here's the bottom of the chassis in TB201. 201 is kind of useful because that allows you to do things like see the 9-volt regulated bus that supplies most of the radio, along with the two 12-volt buses for receive and transmit, and the 40-volt bus that supplies power to the PA. If you look at the synthesizer, you can see that's pretty much a standalone thing. It doesn't work with the external reference or anything like that. It's just one thing with one output. It's nothing like a modern PLL or digital synthesizer. The way they generate frequencies in this is by mixing heterodynes of different oscillators together. And by doing that, that's how they generate the 3.75 to 13.74 output that goes to the first mixer. Your calibration control, when you push that in, basically sets a 10 kilohertz reference oscillator. And what we're going to do is we're going to look at a couple of the test points that are really useful on this. And before you do any frequency measurements on these, there's a couple wires on the TB601 that you want to remove, pin 1 and pin 2. Pin 1 is for transmitter offset, and pin 2 is for the internal calibration oscillator. We'll hook a wire to pin 1 for right now and take that wire and run it to an external 12-volt source. And that forces the transmitter offset oscillator to be in place. Transmitter offset oscillator, when that's engaged, disables the RIT control or the clarifier control on the front of the radio. So go to test point 11. There's test point 11. And we should see 6525 or so on the scope. And it doesn't matter where we turn the clarifier, that should not move. The transmitter offset is set by C612. And also you'll find that if you want to adjust any of the 1 kilohertz offset oscillators, and so our channel 0 is at 6525, so I'm not going to mess with those at all. We're going to go ahead and turn the radio off. And we're going to flip it over and move the jumper over to pin 2. And what this will do is this will force the 10 kilohertz offset oscillator to run. When you do calibrate, it locks the 10 kilohertz oscillator in, and that and the 10 kilohertz reference from the 1.75 megahertz generator are the two things that are used to determine the zero beat. The external jumper just goes to a 12-volt source. It's the same one that's powering the radio. We'll go ahead back to test point 11. And with the 10 kilohertz reference oscillator on, you would use C617 to vary that signal to make sure it's exactly on 6525. So now that our 1 kilohertz and 10 kilohertz reference oscillators are known good, we're going to go back and actually set in a new frequency. I think it's 7850, which is CHU in Canada. peak the radio. And calibrate it. And so we should be on 7850. Let's see what happens if we hook an antenna to it. CHU is actually upper sideband with carrier, so if you're not dead on frequency, you get that heterodyne that was in there earlier. Also, you should kind of note that the receivers on these don't have much in the way of AGC, so you have an issue where strong signals will tend to overload it, so you have to be careful on running the RF gain. Go ahead and peak it down at around 7 megahertz, down in the CW subband. Kind of gives you an idea of its performance on CW. It's upper sideband only, but the CW mode is pretty nice too. Let's try this other radio now. We'll do the same thing. We'll set it to 7850. Peak it for noise. Do the calibration. And we'll bring the antenna in. It's a little harder to do the ground post on this. The strong signal is definitely overloading the receiver, so we'll back that down.
Canada, coordinated universal time, 1 hour.
But you can see that's pretty close to being on frequency. It's a few cycles off. Once again, we'll go down to the CW subband on 40. Peak the receiver. Go ahead and throw the other receiver back in its box. Go ahead and get this snapped back together. We'll get the battery box and install it back on top of the battery box. And you can see that although this is a 60-year-old design, it's still a very good radio. It's like a little QRP, parks on the air, or field use. We've used them a lot on 60 meters on 53, 57, so it's a pretty good radio. Originally, my friend Joe Munson was the one who first told me about the 74s and their inherent goodness. He had extensive use using these things in Vietnam and Cambodia and Laos, so kind of dedicate this video to him.